Hello everyone, myself Sasireka, Academic Coordinator, Department of Computer Science, Artificial Intelligence and Data Science. Today let us discuss about the software system introduction. Software system strategies are pivotal for organizations aiming to optimize their operation, enhance productivity, and stay competitive in today's dynamic digital landscape. These strategies encompass a range of approaches tailored to harnessing the power of technology effectively. By strategically aligning software system with business objectives, organization can leverage them as a tool for growth and differentiation. Central to these strategies is the recognition of software system as critical assets that not only streamline process but also drive the innovation enable strategic decision making. Central to these strategies and recognition of software system as critical assets that not only streamline process but also drive innovation and enable strategic decision making. Software system strategies. Software testing is the process of evaluating software application to identify if it meets specified requirements and to identify any defects. The following are common strategies. Black box testing. Test the functionality of the software. Focuses solely on the external behavior of the software, disregarding its internal structure, design, or implementation details. Testers approach the system as an opaque entity interacting with an end user world without any knowledge and its external working. Input output analysis, independence from implementation, equivalence partitioning and boundary value analysis, plus functional and non-functional testing. These are the important key aspects of the black box testing. In independence from implementation, black box testing ensures independence from the underlying code base or programming language used to develop the software. This allows unbiased assessment of the system functionality, making it suitable for testing at various stages of software development lifecycle. Techniques such as equivalence partitioning and boundary value analysis are commonly employed in black box testing to maximize this test coverage while minimizing the number of test cases. Black box testing encompasses both functional and non-functional aspects of the software. Functional testing evaluates whether the software meets specific functional requirements or not, while non-functional testing assesses the factors such as performance, usability, reliability, and security. This white box testing. These are all the key aspects of white box testing: internal structure examination, code coverage metrics, control flow and data flow analysis, unit testing and integration testing, error handling and exception testing. In the case of internal structure examination, white box testing, also known as glass box testing or structural testing, involves scrutinizing the internal structure and implementation of the software. Testers have to access the source code and use this knowledge to design test cases based on the programming logic, branches, paths, and data flows. Code coverage metrics. White box testing aims to achieve high code coverage by exercising various paths and branches within the code base. Control flow and data flow analysis. Testers analyze the control flow and data flow within the software to identify potential vulnerabilities, logical errors, and inefficiencies. This involves tracing the execution paths of the code and examining how the data is manipulated and transmitted throughout the program. Unit testing and integration testing. White box testing is commonly associated with unit testing, whereas individual users units or components of the software is tested and in isolation. Error handling and exception testing includes testing error handling mechanisms and exception paths within the code base. Testers deliberately inject false and unexpected inputs to evaluate how the software responds to exceptional conditions such as invalid inputs, resource constraints, and system failures, ensuring robustness and reliability. Unit testing. The important key aspects are focused individual units, automated testing, black box and white box testing, test-driven development, isolation and dependency management. Focused on individual units. Unit testing involves the testing individual units or components of the software in isolation, typically at the code level. Automated testing. Unit tests are often automated, allowing for efficient and repeatable testing code changes. Black box and white box testing. Unit testing can incorporate both black box and white box techniques. White black box testing. focuses on testing the functionality of units without the knowledge of their internal implementation. White box testing delves into internal logic and structured units ensured through the coverage. Test driven development. um, Developers write unit test before writing the actual code, guiding the implementation process and ensuring that the code meets specified requirements. Um, Isolation and dependency management. Unit test should be isolated from the external dependencies such as database, file system, network services, and ensure reliability and repeatability. Integration testing. um, Testing the integration between the components. Types of integration testing: interface validation, stubbing and mocking, end-to-end scenario testing. The types of integration testing where it takes the various forms including top-down integration, bottom-up integration, hybrid approaches. Interface validation: it validates the interface between the components, ensuring the data exchanged correctly and that inputs and outputs processed as expected. Stubbing and mocking: to isolate components during the integration testing. Stubs and mocks are often used to stimulate the behavior of dependencies that are not yet available or difficult to replicate in the testing environment. End-to-end scenario testing. Integration testing also encompasses end-to-end scenario testing, where complete workflows or business processes are tested across multiple integrated components. Functional testing. Validating functional requirements. Functional testing involves the verifying that the software function according to specified functional requirements. Black box testing approaches primarily conducted from the black box perspective, whereas testers interact with the software solely based on its externally observable behavior without knowledge of internal implementation. Test scenarios and use cases. Functional testing encompasses the creation and execution of test scenarios and use cases that covers various aspects of the software functionality. Positive and negative testing. Functional testing involves both positive and negative testing scenarios. Positive testing validates the expected behavior and functionality under normal operating condition, while negative testing examines how the system handles invalid input, error condition, etc. Regression testing. Functional testing plays crucial role in regression, where previously tested functionalities are retested to ensure new code changes or system updates have not introduced uh, side effects or regression. System testing. So these are all the key aspects of the system testing. Testing an integrated system, end-to-end testing, non-functional testing, acceptance and regression testing. Testing an integrated system involves the testing of entire integrated software system as a whole rather than the individual components or units. End-to-end testing test includes the software application covering all aspects of its functionality, user interface, data flows, and interaction with external systems or dependencies. Non-functional testing. In addition to functional testing, system test also encompasses non-functional testing to evaluate aspects such as performance, scalability, reliability, usability, security, and compatibility. Acceptance testing. Testing often includes acceptance testing, where stakeholders or end user validate whether the software meets their requirements or expectations. Regression testing. Testing incorporates the regression testing to ensure new changes and enhancements do not introduce regressions or unintended side effects in the existing functionalities. Acceptance testing. So these are all the important key aspects. Validating business requirements. Acceptance testing is focused validating that the software meets business requirements and objectives defined by the stakeholders. User-centric approach conducted with the primary goal of ensuring that the software meets need of expectations of the end user. Formal sign-off process. Acceptance testing typically involves formal sign-off process by the stakeholders or designated representatives to indicate their approval of the software for production release. Alpha and beta testing. Acceptance testing may include both alpha and beta testing phases. Alpha stage is conducted by the internal stakeholders or selected users and controlled environment, while beta testing involves releasing the software with broader audience of the external users feedback getting from the real world. Regression testing. Test coverage. Regression testing involves ensuring the comprehensive test coverage across the entire application or affected areas. Automation. Regression testing often relies heavily on automation to efficiently rerun existing test cases to verify no new defects has been introduced. Prioritization. High risk areas and critical functionalities, it will be focuses on version control integration. Regression testing should be integrated with the version control system to track changes continuous integration and deployment. Regression testing is a integral part of CI/CD pipelines where automated tests triggered automatically upon the code changes new deployments. Performance testing. Identifying performance metrics is performance testing involves identifying and defining relevant performance metrics such as response time, throughput, scalability. Scalability testing. Performance testing includes the scalability testing to assess the software ability to handle increased workload or user concurrency while maintaining acceptable performance levels. Load testing. Load testing is the key aspect of performance testing that evaluates the system behavior under expected and peak load conditions. Stress testing evaluate the system stability and robustness under extreme or beyond normal conditions. Monitoring and analysis involves the continuous monitoring and analysis of system performance metric during the test execution. Security testing, identifying vulnerabilities. Security testing involves assessing weakness and potential threats in the software system. Threat modeling. Security is often being with threat modeling where testers identify potential security threats, attacks vectors and entry points into the system. Penetration testing. Penetration testing is also known as ethical hacking. Is a key aspect of security testing that involves simulating real-world cyber attacks to evaluate the effectiveness of the system security controls. Security standard and compliance includes verifying compliance with industry standards, regulations, and best practices related to the information security. Security controls and countermeasures. Security testing evaluates the effectiveness of the security controls and countermeasures implemented within the software system.